The universe hides its most violent secrets in silence. No warning, no mercy, just a blinding light, brighter than billions of suns. And then, darkness. This is the story of a death. Not just any death, but the death of stars, the titans of creation, and the architects of everything we are. When stars explode, they do not fade quietly. They tear themselves apart in one of the most destructive and breathtaking events in the cosmos, a supernova. Imagine for a moment the night sky above you, silent, peaceful. You see familiar constellations twinkling faintly, but hidden among those dots of light, somewhere, right now, a massive star is burning out its last moments, a fuse shorter than we can comprehend, a storm building that will unleash more energy in seconds than our sun will release in its entire lifetime. That star will not simply die, it will take half the galaxy's breath away. Supernovae are both killers and creators. They are the violent funerals of giant stars, but within their destruction, they forge the elements of life. Every atom of iron in your blood, every grain of calcium in your bones, every trace of gold in your veins, forged in firestorms that could incinerate worlds. Without supernovae, we would not exist. But what exactly happens when a star explodes? To answer this, we must travel inside the heart of a massive star. Picture a furnace of unimaginable heat, where hydrogen atoms smash together, fusing into helium. This is the star's heartbeat, its endless struggle against gravity, a fight to keep from collapsing inward. For millions, sometimes billions of years, the star burns peacefully. But fuel is finite, and once hydrogen is gone, the core begins to fuse heavier elements. Helium into carbon, carbon into oxygen, oxygen into neon, then magnesium, silicon, and finally, iron. Iron, the cosmic dead end. It cannot release energy by fusion. It cannot support the star's weight. And once the core is filled with iron, the balance shatters. Gravity wins. The collapse happens in an instant. The star's core implodes, shrinking from the size of Earth to the size of a city in less than a second. Temperatures soar to billions of degrees. Protons and electrons slam together, creating neutrons. The entire core becomes a single, crushing neutron sphere. And then, the rebound. The outer layers slam inward, hit the core like a wall, and ricochet outward in a titanic explosion. This is a supernova. In that instant, the star shines brighter than an entire galaxy of hundreds of billions of stars. Light surges across the cosmos, radiation floods space, and matter, torn from the star's body, is hurled into the void at 10,000 kilometers per second. If such an explosion happened near Earth, we would not survive. The blast would sterilize our planet, strip away its atmosphere, and reduce life to ash. Supernovae are not fireworks. They are cosmic weapons, nature's nuclear bombs. And yet, from this violence comes beauty. The Crab Nebula, a ghostly cloud of gas and dust, remains of a supernova witnessed by Chinese astronomers in the year 1054. They wrote of a new star so bright that it could be seen in the daytime sky for weeks. What they were seeing was death, but also rebirth. Because every atom blown into space during a supernova becomes raw material for new stars, new planets, and perhaps new life. Look at the gold on your finger, that shimmering necklace, the steel in a skyscraper, even the oxygen you breathe. All of it was forged in a star's death. We are made of supernovae. We are literally stardust, walking, breathing, thinking. But not all supernovae are born equal. There are two great killers in the universe, and they strike in different ways. The first, core collapse supernova, the death of massive stars, at least 8 times heavier than our sun. These giants burn fast, live short lives, and end in fury. The second, type 1a supernovae, Not the death of a single giant star, but the betrayal of a partnership. Picture two stars orbiting each other closely. One dies, collapsing into a white dwarf, a dense, Earth-sized ember of a star. But it is greedy. It pulls matter from its still-living companion, stealing hydrogen, draining its partner dry. The white dwarf grows heavier until it can no longer hold its weight, and in a final act of cosmic theft, it detonates, obliterating itself and its partner in a catastrophic explosion. These supernovae are so precise in their brightness that astronomers use them as cosmic lighthouses to measure the expansion of the universe. But supernovae are more than astronomy textbooks. They are warnings, because the universe has no shortage of ticking bombs. Our own Milky Way harbors dozens of stars destined to go supernova, some within our lifetime. Take Betelgeuse, the red supergiant in Orion's shoulder, a monster star burning so violently it is near its end. One day, tomorrow, or 100,000 years from now, Betelgeuse will explode. When it does, the night sky will never look the same. It will shine brighter than the full moon, visible even in daylight, and the world will watch in awe. Fortunately, Betelgeuse is far enough that Earth will not be harmed, but the spectacle will remind us of a chilling truth. Our cosmic neighborhood is not safe. There is, however, a darker possibility, one that keeps astronomers awake at night. The gamma-ray burst. When certain massive stars collapse, they don't just explode. They focus their death throes into twin beams of radiation, narrow and deadly. If one of those beams were pointed at Earth from nearby, it would sterilize our planet in seconds. Oceans would boil, the ozone would vanish, and life as we know it would be erased. Some scientists believe such events may have already wiped out life on Earth before, a silent killer from the stars. Yet still, without these explosions, we would not exist to fear them. Without their violence, the periodic table would be incomplete. Without their fury, galaxies would be barren. Supernovae are the paradox of creation. They destroy to give life. They kill to seed the future. Think about this the next time you look up at the stars. Somewhere out there, a giant is dying, its last breaths building toward an explosion that will light up the universe. Perhaps the atoms of your body are waiting in the core of some distant star, to be forged, hurled into space, and one day reborn in another form of life. Supernovae are not just cosmic fireworks. They are the universe's way of recycling itself. The end that begins everything again. We fear them. We admire them. We owe them everything. When stars explode, they write the story of the cosmos and the story of us.